The Indian Space Research Organisation ISRO reached new heights today as it successfully launched the Aditya L1 solar mission from the Satish Dhawan Space Centre in Sriharikota, Andhra Pradesh. At precisely 11:50 am, the towering 44.4-meter tall Polar Satellite Launch Vehicle C-57, PSLV C-57, embarked on its journey into space, lifting off from the second launch pad. With a hefty lift-off weight of 321 tons, the rocket gracefully soared into the heavens, trailing a vivid orange flame in its wake. The rocket's ascent, accompanied by a rumbling sound akin to rolling thunder, enthralled spectators at the viewers' gallery, who cheered and applauded with immense pride. Approximately 63 minutes after liftoff, the PSLV C-57 successfully released the Aditya L1 spacecraft, marking the culmination of the mission roughly 73 minutes after the passivation of the fourth stage. Aditya L1 represents India's pioneering venture into space-based solar research. The spacecraft will be positioned in a halo orbit around Lagrange point 1, L1, within the Sun-Earth system, located approximately 1.5 million kilometers from Earth. This unique orbit offers a distinct advantage: an uninterrupted view of the Sun without the interference of occultations or eclipses. This vantage point will enable real-time observation of solar activities and their impact on space weather. The Aditya L1 mission carries 7 payloads designed to observe the Sun's photosphere, chromosphere, and the outermost layer, the corona, using electromagnetic, particle, and magnetic field detectors. 4 of these payloads are dedicated to direct solar observation, while the remaining 3 focus on in-situ studies of particles and fields at Lagrange point L1. These instruments are pivotal for scientific investigations into coronal heating, coronal mass ejections, pre-flare and flare activities, the dynamics of space weather, and the propagation of particles and fields in the interplanetary medium. Mission's key scientific objectives encompass studying solar upper atmospheric dynamics, investigating the dynamics of the chromosphere and corona, exploring coronal heating, examining the physics of partially ionized plasma, the initiation of coronal mass ejections, and flares. In situ particle and plasma observation, providing data on particle dynamics originating from the Sun. Corona physics and heating mechanism, unraveling the mysteries of the solar corona and its heating mechanisms. Diagnostics of plasma in the corona and coronal loops, measuring temperature, velocity, and density. Understanding coronal mass ejections, CMEs, investigating the development, dynamics, and origin of CMEs. Analyzing space weather drivers, identifying the origin, composition, and dynamics of the solar wind. The Aditya L1's instruments are finely tuned for solar atmosphere observation, with a focus on the chromosphere and corona. In situ instruments will monitor the local environment at Lagrange point L1. In total, the mission carries 7 payloads, with 4 dedicated to remote sensing of the Sun and 3 to in-situ observations. This ambitious endeavor represents a significant leap in India's scientific exploration of the Sun, offering the potential for groundbreaking insights into our nearest star and its profound impact on our solar system.